Tashi Dali, thank you for joining me today as I talk about our project in the High Himalayas, where we are working with local communities to understand their aquifers in order to improve access to and management of water resources. To start, I'd like to thank Geoscientists Without Borders and Ball State University for their support of the project, and our partners at Kathmandu University, Action for Nepal, and the Nepali National Park Service. Communities in the high Himalayas regularly experience water vulnerability. Our previous work shows that there is a problem with water contamination throughout the region. Note the figure on the upper right, which plots colony-forming units of E. coli, a fecal coliform, per 100 ml sample versus location. The locations shown are all drinking water sources, mostly springs. Much of the water sample contains more than 10 colony-forming units, putting the water into the moderate to high risk categories according to the World Health Organization. Water contamination is due to the high number of tourists, a lack of infrastructure, and poor water handling. Our work has also shown that the high altitude communities are highly dependent on glacial meltwater for their drinking water. The lower figure on the right uses oxygen deuterium isotopes to calculate the percentage of glacial melt contribution to the drinking water source. Combined with glacial melting and changing monsoon precipitation patterns, this data predicts increased water vulnerability for the region, which the local Sherpa communities are aware of and concerned about, particularly the communities we're working with. Our project is based in the Sagarmatha National Park of Nepal. Famous for Mount Everest, the region was made a World Heritage Site in 1976. It has a small local population of predominantly Sherpa ethnicity and hosts large numbers of tourists each year. In 2022, we completed phase 1 of our project, which was to work with the village of Phorste, shown here in the red circle. Our project has 4 main phases, which are firstly, community engagement and sharing of results. Secondly, water sampling and testing. Third, an ERT, resistivity survey. And fourth, sustainability, which encompasses 3 smaller projects, including tourist perceptions, climate modeling, and new threats such as microplastics. Community engagement is fundamental to this project. We started our community engagement with facilitated community meetings, both at the beginning of the project and again at the end of the project. To start with, we really wanted to make certain that we understood the community needs and that the community understood our work plan and how our work plan was going to mesh with their needs. We also conducted semi-formal interview surveys of community members to see what they felt the biggest issues were and if those corresponded or agreed with what we'd been told and what we had been led to believe. As you can see here, most people in the community felt that glacial melting was their number 1 concern. Secondly, water quality, fire control, which comes back to water. Basically, all of these issues are about water. At the end of our trip, we hosted another community meeting where we delivered our preliminary results and discussed what could be done with the information, how it can be best utilized. Continuing the theme of community engagement, understanding, and knowledge sharing, we conducted 9 semi-structured stakeholder interviews in Phorste and 20 key informant interviews throughout the region. Key informants are local government officials, business owners, NGOs, and Sherpa community leaders. Both sets of interviews really showed the same common themes, and those themes were economics, environmental issues versus tourist dollars, agriculture, education, and really predominantly climate change and water projects. The preliminary analysis of these interviews really revealed a general feeling of uncertainty over long-term water solutions and a lack of understanding of water quality throughout the region. The second phase of our project was water sampling and testing. Throughout the region, we sampled 68 different water sources, including 9 bottled water sources, which are bottled locally from springs and sold primarily to tourists. We also sampled Phorste community water, mostly households, and then the remaining samples are drinking water taps and also springs that are used for community drinking water. We measured physical parameters, pH conductivity, total dissolved solids. We measured E. coli, and then we took the samples back to the lab where we did cation, anion analysis, oxygen deuterium, and carbon isotopes. One of the main findings of this summer's work was that 66% of the bottled water samples contained fecal coliforms, 87% of the Phorste water, and this is their new water supply, contained fecal coliforms, and across the entire region, 97% of all of the water samples that we took had fecal coliforms, with roughly 65% being in the moderate to high risk range of the World Health Organization. A major part of our project was the electrical resistivity tomography survey. We ran 6 major lines across the major horizontal lines across the village before we experienced irreparable equipment failure. The results of our lines, we got our main lines done, and the results show that the southern boundary of the village, southeastern boundary, is underlined by more than 100 meters of glacial till, which means it's not a good place to build. Secondly, one of our lines showed that the bottom part of the village had multiple shallow flow paths but no deep reservoir. One of the newly built water storage facilities is close to bedrock, which makes it fairly stable during an earthquake, but the second tank is built almost entirely on glacial till, well, entirely on glacial till. The most important result of our work, shown here in the line, the ERT survey line in this picture, is showing that there are 2 potential groundwater sources somewhere between 70 and 90 meters depth, and this is during the pre-monsoon dry season. From our additional lines and our local knowledge, we believe that the water from these sources is following those blue lines coming down through the upper portion of the village and then both hitting the surface. The northern line actually is the old village spring where it comes out, and the other water actually turns into shallow flow throughout the glacial till. Long-term planning and sustainability is fundamental to reducing water vulnerability in this region. To this end, we've begun several peripheral studies to help ensure the success of the project. One of these projects involves understanding and influencing tourist behavior in the region. In the field experiment, trekkers were given a field survey asking about their willingness to pay for public toilets and their willingness to pay refundable bottle deposits. While each respondent was asked their willingness to pay for these 2 things, we randomized how the questions were conditioned for each respondent. In the attitude survey, we took a different approach to willingness to pay for environmentally friendly toilet facilities. We employed Adson's theory of planned behavior, a model commonly used to explain how individuals make decisions to engage in pro-environmental behavior. Our goal was to identify whether their willingness to pay was most strongly influenced by their perceived behavioral control, attitudes, or responses to the norm. Basically, this information helps the communities decide what the best way forward is to reduce the contamination of their water resources, i.e. environmentally friendly toilets, and the waste in the region, i.e. plastic water bottles. Last but not least, in order for communities to effectively manage water resources and plan for the future, they need to understand long-term implications of climate change and be aware of new threats. 2 more of our ongoing projects, both in the initial phases, involve climate modeling specific to the high Himalayas and characterizing microplastics in the water sources, mostly springs and surface water. In 2022, we sampled 25 rivers and springs. All of our samples contain microplastics, and they ranged from films to fibers and fragments. That data is being processed now. Our climate modeling, again in its infancy, is using temperature and precipitation data from the region to check and predict trends in the high Himalayas. The modeling is using autoregressive integrating moving average, ARIMA modeling, and multiplicative, I always struggle with that word, seasonal autoaggressive integrating moving average, SARIMA modeling to forecast temperatures and precipitation. We're validating that model with observed data up until 2021 and then using it to expand out to 2050. I think our project really illustrates clearly how complicated issues are around water security and water vulnerability, particularly in this time of climate change. Our hope is that by providing the villages such as Phorste the data necessary to understand their water resources, both their surface water and their groundwater, combined with a better understanding of tourist and resident perceptions, attitudes, behaviors, and all of these different variables that are feeding into and impacting their water issues, that the villages will be able to manage and plan for long-term water security in what is an ever-changing dynamic. And again, I want to thank the village of Phorste, and I want to thank Geoscientists Without Borders, and thank you all for listening to my presentation. And please contact me if you have any questions. Thank you very much.
Hello, my name is Gabriel. I'm a geological engineering student at the Federal University of Ouro Preto. I am a member of the SGA, the Applied Geophysics Society, and along with the SEG, we are conducting a project, Geophysics Applied to Geotechnical Studies in Ouro Preto. And I'll be telling you a little about this project. So, Ouro Preto was founded in the 18th century under the name of Vila Rica, mainly because many explorers came to the city searching for riches through the gold mining. And nowadays, the city is considered an open-air museum since it still preserves most part of the historical center and considered a World Heritage by UNESCO. So the city is located in a region we call the Iron Quadrangle, a highly deformed region where the outcropping rocks are mostly metasedimentary, such as phyllites, quartzites, and schists. And here we have the area of study located in the eastern part of the city and includes 4 different neighborhoods. Uh, Here we have the geological map in the project area. So in this area, the urbanization process happened very fast and without planning, and combining this with the highly deformed rocks and the high slope terrain, also with some cavities left behind by the gold mining, we have an area which is extremely prone to natural disasters, putting thousands of lives at risk. And that is where our project aims to act, using geophysics uh, as a low cost and non-invasive technology to try to investigate those areas and warn the population. So how are we doing this? The first step is the interpretation of regional gamma spectrometry and magnetometry data gathered from the Brazilian Geological Survey. And also we conducted some drone surveys using the aerophotogrammetry technique. The next step was the local geophysical investigation. In some critical areas, we detected through the drone surveys and the partnership with the Civil Defense of Ouro Preto, a public facility that works directly in those hazard areas. So we conducted gravimetry surveys to investigate those cavities, and magnetometry surveys to investigate subsurface structures. The next step was the electroresistivity survey to investigate the presence and flow of groundwater. And finally, combining all the data, we constructed a booklet to distribute to the community and also a handheld to distribute in schools in the area of the project. So, what have been done so far? First of all, the regional data integration. Here we have some examples of the gamma spectrometry, the ternary image overlaid with the geological map. This helps a lot to identify different lithologies in the detailed mapping phase. The regional magnetometry to identify some structures. And with the 3D visualization of the ordered convolution technique, we were able to identify some structures that were up to 900 meters deep. So with those critical areas defined, we were able to also define some detail profile lines where we conducted the detailed geophysical surveys. So here we have examples of the drone surveys, the gravimetry and magnetometry, and also the electroresistivity. So our project were postponed by another 6 months, so we can conduct the electroresistivity surveys also in the rainy season to get better results. So what about the project disclosure and knowledge dissemination? Through our project, we were able to start 4 different theses. We divided the area into different smaller areas, and the 4th thesis is responsible for the detailed geological mapping. And here we have an example of the first booklet we built to distribute to the community. And the handheld we are distributing in schools to warn also the children in the neighborhoods. So finally, I'd like to thank our partners at the SEG and the GWP program, the Federal University of Ouro Preto, the National Observatory, who lent us the necessary equipment to conduct those terrestrial surveys, the Civil Defense of Ouro Preto, Brazilian Geological Survey, Bog Geophysics, who also lent us some equipments, Zemlya Geotechnical Studies, and finally the School of Mines of Ouro Preto. Thank you very much. Any doubts, you can contact us to the information appearing on the screen.
Wow, great talks from our 2 speakers, Kirsten and Gabriel. Now we'll move into our discussion session and get to as many questions as time allows. I don't see too many questions in the chat right now, so I'm going to get the ball rolling by asking a question myself. So my first question is for Dr. Kirsten. In your talk, you mentioned that some of the things that affect the water quality were glacial melt, earthquakes, fecal contamination. And my question is, since fecal contamination is the component that you can most easily address, is your plan to continue your emphasis on the remediation efforts there? And do you know if anybody or any other research group is trying to look at anything related to the earthquake or glacial related issues?
I do know that there are groups looking at earthquake risk, not so much in the high mountains, mostly lower down. And the fecal quality work, contamination work is, I mean, it's easy to do. So while we're there, we do it and give that data back to the communities. And that's where a lot of the tourist stuff ties in, because the communities are really afraid to start charging tourists so that they can build septic systems and proper waste management. And so they really want that data about tourists. Will tourists pay? And it's crazy because, you know, it's only a couple dollars extra. They're only looking at charging tourists who pay thousands of dollars to get to the region and trek to Everest Base Camp. And yet, you know, the communities are afraid to charge them a few extra dollars. And so they really want that data. You know, will tourists pay? And so far the results have been saying yes.
No, that's good to hear. Awesome. There's one. A question from Karen. I see, how much tourist feedback survey did you receive? That's such a great piece of communication.
We did two different tourist surveys. One was one was actually a little experiment to see if you could change the question and if the answers would change. And so the shorter survey, we had 240 responses, and the longer survey we had 200, because the longer one only took 5 minutes, but it still put people off.
Yeah, no, perfect. And then another question I had in my notes is, you mentioned your 4-piece step Phorste Village work plan, and which of those steps did you find like the most difficult with, and what components do you think you need to like kind of revisit or augment or enhance to continue the remediation process? Because there's so many kind of cogs in that process.
A lot of cogs in that wheel. The hardest thing was the ERT survey at 4,000 meters altitude. I learned really quickly that I couldn't get my team to do 3 lines in a day. They were exhausted. Usually 1 line was enough. And so, and also we went through 3 generators and I had only purchased 2. So, they just, so dusty and windy, the generators broke. And so there was a lot of equipment failure and a lot of exhaustion. And so I think that was definitely the hardest part of the project.
Makes sense. And then I guess in terms of where you're at with your research right now, what are like your current like next steps or like future outlook for this project?
Right now we're getting all I've got multiple student projects working on the data, and hoping to have it all on a website that we will share with the communities in the next, definitely before the end of the year. And then we're moving on to we're going to do the same project with a different village, but still go back to Phorste, and they're really interested in looking at ways to fund money to drill a well. And so we're going to not take over that, but sort of help them with that phrasing, the wording, and the writing of that application.
Yeah, and then what data have your surveys yielded like thus far? Like, does the data responses change how you want to survey in the future? Because you already mentioned that, you know, that 5-minute thing, no, that's too long to captivate. But I guess I'm curious what you're kind of learning from the data you're getting and what you're gonna do with that data.
I think in terms of our approach in general is going to be the same next year, and partly that's because it makes it very comparative, especially the survey data. And, you know, we still got 200 responses. That's pretty, you know, it's statistically relevant. So, but next year we're going to bring another couple of students to work on the survey data, or at least a student to work on the survey data. And in terms of the ERT survey, basically we're taking more students next year, and my plan is to rotate people so that everyone does 1 line, but if we have enough people, we'll do 2 lines in a day, and that will make it easier for everybody.
Yeah, perfect. The next question I see in the chat is for Gabriel. Gabriel, the question is, can you discuss how the information provided in the printed materials was used by the schools? Did you do any additional outreach or activities with the schools?
Hello, everybody. So the material we are distributing to the schools, we didn't start to distribute yet. That was just a preview of the material. So we will start the distribution next year, actually, early next year.
And what's the plan for that? If you can elaborate, like how many schools are you sending that to? Like, is it just localized in the region where they're affected? Like, kind of what's the scope of that, I guess, outreach?
Yeah, we have to talk to the responsible for the school first, and we have already 3 schools that agreed to receive us and let us distribute the material, but we aim to reach much more schools. But we have to have that conversation first with the responsible.
Yeah, no, that makes sense. And then Gabriel, in my notes from your talk, a question I had just for clarification and context of kind of your environment and the situation you're doing this research in is, do you know exactly when, just for context for the viewers, when did the gold mining stop in Ouro Preto, or is the mining still operational? Is it something that's still ongoing there?
No, it's not operational because the city is considered an World Heritage by UNESCO, so you can't mine nothing in the city.
Yeah, no, perfect. That answers it.
Yeah.
Yeah. And then are you aware of any other geophysical projects or any projects in general that are also focusing on that geohazard assessment risk that's prevalent in that area?
In the university here in Ouro Preto, we have some works that studies some other stability issues around the city, but not not using geophysics or not as big as the GWB.
Perfect, thanks. And then you also mentioned like the 4 stages of your methodology in your process of how you kind of like set up this project. And I guess I'm wondering, what stage have you found the most difficult with so far? Like where have you run into the most issues?
Oh, definitely the electroresistivity service, because the area where we're going to apply the survey, the areas are very unstable, so we have the safety issue as well. So it's not everywhere that we intend to go that we can actually go. So we have to think our ways around it. It's kind of difficult.
Yeah. And now I see I have a question in the chat for you. How has gold mining affected the local environment? Are you planning to apply geophysical methods to some other aspects?
So the gold mining, when it left many cavities behind in the, you see the landscape of Ouro Preto is full with hillsides and very sloped terrains, and the gold mining left some pretty big cavities, and it can potentialize the risks of landslides and rockfalls. So identifying those areas will help prevent those disasters.
Yeah. And then where you are currently with your research right now, what are like your current like next steps and outlooks for your project? What's kind of the next phase of your process?
So the next phase is to conduct the electroresistivity surveys in the rainy season, which we are entering around now. I think next month will be raining a lot around here. So that's the next step we intended to take.
And then I guess to elaborate on that, when you have your rainy season, how does that, where do you see that greatly like impacts your data and like kind of your research? What is it like kind of the map, like what are you looking at as the extremes versus the rainy season versus the non-rainy season?
First, we are looking for differences in the landscape if we have more landslides happening, or if the area became more dangerous for the population, and mainly the water flow, the underground water flow, that in the rainy season will be very clear to see.
Yeah, perfect. I'm actually gonna pivot back to Kirsten because I had a question that I'd start because I was really curious about it in your talk. Because I know, like, especially with Earth Science Week, I know a lot of these projects that we're highlighting are really about like communication and outreach and like, you know, incorporating people who aren't scientists about like what's going on, about how geoscience applies to their lives. And I know you're very, you're in your research, you're very sharing with the villagers and the local community what's going on, so they're part of it. When you shared the E. coli results with the local village, because that was something that was like, you know, made my jaw drop when I saw like the numbers you had. When you shared those E. coli results with them, what was their response? How did they perceive that?
Well, actually, it was interesting because in general the communities are really upset about that. Let's start with that. They're pretty shocked because the water looks so clean, and the tourists the same. You tell the tourists that they shouldn't be drinking the water, and they're usually shocked because it looks so clean and so fresh and straight from the glaciers. So there's that aspect. There's the initial shock. And then you start talking, and you hear about dysentery and seasonal illness, and you find out that actually there's a real pattern of people getting sick, particularly as soon as the rains come, as soon as the monsoon comes. And then the other amusing thing in Forche, it's not amusing, is that there's somebody sabotaging their new water plant. And so they've got somebody who's coming along, and they think they know who it is, but they're not sure, and cutting the distribution lines. And so Forte's water coming directly out of their water filtration system is good. But by the time it gets to the households, it's not, because somebody's actually in the village is sabotaging it. So they were not completely surprised when they got that information, and it really confirmed that what they had thought was going on.
Oh wow, I wonder what the motivation for that sabotage is. That's very interesting.
It's actually crazy, because they bury the water lines, and so somebody's going around and sticking, they think, a shovel or something to break, and it's crazy. So anyway, it's something they're working on, clearly.
Yeah. The next question I see in the chat is actually back at you, Gabriel. As you mentioned, depression because of gold mining, what are the probabilities of landslides happening? So how are you planning to work with the community in these regards? I guess he's asking about the frequency of landslides in that area because of gold mining.
Directly because of gold mining, we have just a few ones where the cavity, forgot the word. I mean, the ceiling fell down and everything's above also fell down. But the most parts are due to most landslides that occur in the area are due to the discontinuities underground and the soil differences. So due to the cavities, is investigating the cavities are just a precaution to add something more to the project.
Yeah, no, perfect. That makes sense. And then something I was gonna that I wanted to touch base with you on is, it's interesting to me how you're using so many different techniques to collect data from this research to kind of just capture a whole bunch of different viewpoints as to what you're seeing going on. And I guess, like, from your research, I know you still have a lot to go on this project, but what techniques so far have you seen like yield the most profound results? Like, what, because you've done so many different ones, where have you gotten, I guess, the best data, or data you didn't expect to get, something that's kind of helped highlight or show you what's going on in this research from all your techniques?
Mainly the magnetometry, because we are able to see the underground structures. And in the area, in the past, we have a lot of hydrothermal activity, really rich in iron oxides. So conducting magnetometry are easy to see those discontinuities where the iron oxides are located. So it's easier to use magnetometry because the results are actually really better.
Yeah, no, perfect. And then are there any other techniques besides the ones you listed that you are planning to incorporate in this research in the future, or are you just going to continue on with the ones you have to kind of compare data over time?
Yeah, we don't have any plans to add another technique, just continue working with these ones we have.
Yeah, no, perfect. And then I'm going to go back to Kirsten here. My next question is, like, you mentioned that there's those 2 new sources of water in the area. What level, based on your gut instinct, or I guess data, if you have it from what you've already seen in that area that you're familiar with, how contaminated do you anticipate those two new bodies of water to be? And what issues, and then you mentioned it a little bit with the glacial till and stuff, and like, you know, acquiring that water. But I guess I'm curious as to like what you see as the feasibility and what issues you would anticipate accessing those two other sources of water.
I think that so the two different bodies of water, and this is we're doing pre-monsoon dry season surveys, and I think that the deeper aquifer is in a fault, and that's probably potentially problematic. However, it's more likely to be the cleaner body of water because the water isn't coming through a pile of glacial till. On the other side, where we see groundwater at about 70 meters depth, there's a lot of glacial till sitting above that, down to about 40 meters depth, and so there's more potential for surface water contamination in that. So they're both slightly problematic, but I think we need to do a tiny bit more work and figure out if we can go back up the hill slope on the one side, on the eastern side. I think we might be able to get beyond that potential surface contamination.
Yeah, that makes sense.
And
then
going back to the fecal contamination, I wanted to add that the bottled water fecal contamination was probably the one that caused the biggest stir, by the way, because they're selling that to tourists, and when tourists get sick, they blame restaurants they've eaten at, not the bottled water.
And something I wanted to add on to that, you know, you have all this data now of what the water looks like now and where the contamination issues are, and you're looking at kind of like all the inputs and outputs as to like what's causing all these things you're seeing. I guess I'm curious if there's any historical data, and I don't know how much you've kind of looked into this, like in your background research, of what the water quality was prior to the tourism rising in that area versus what it is now, because it'd be interesting to see what the water quality was like prior to all the changes that have happened in that area.
There's no data at all. There was a team about 2010, an Italian team went in and did water quality work, and they didn't publish the work, and I gather they took about 12 samples, but by 2010 probably the water was mostly contaminated. You assume historically the water, if you go back 70 years, would have been significantly better because 70 years ago they didn't have the tourists they have now. And you know, all of those early mountaineering teams drank the water, but there's no data.
Yeah, no, that makes sense. And then I guess another point I want to bring up is you mentioned that like they're selling a lot of these bottled waters to tourists. There's kind of like, you know, you did those surveys of like, would you be willing to spend more money for water with all these practices we want to implement in place? And I guess I know and obviously the socioeconomic status of the villagers who live there is very different than these tourists who are spending thousands of dollars to come here and visit and do their excursions. What do you anticipate is going to be like? I mean, there's a difference between being fair and what actually happens in practice. What do you expect to be like the monetary distribution of who's going to bear the cost for maintaining like the recycling of the water bottles and the upkeep of the toilets that the truckers and stuff go by? Where do you kind of envision like that like costs being like distributed?
I think, you know, the fundamentally, you know, the only source of income in the region is tourism, and so at some level, tourists will bear the cost of that. But you have to remember that the average wage, unless you're a Sherpa mountaineering guide, you know, the average wages are really low, and so for a tourist to spend, you know, 20 cents to use a toilet that is got a lined septic system, or one of the things that I think long term the region is going to look at is a refillable bottle scheme where you know, buy a water bottle initially, and then can fill it up at all the different tea houses for either free or a nominal cost. But you know, we're talking, you know, so for the water, we're talking maybe $20 for a 2-week trip.
Yeah.
So it's just a matter of getting everybody on board and realizing that it's feasible, because $20 when you've spent so much money to get there is not very not significant, but for the local community it is significant. So there's an impasse there right now.
Yeah, no, thanks for that context. That makes complete sense. I just wanted to clarify. And
Yeah,
then
yeah.
I'm seeing we have two more questions in the chat here. The next one is livestock a significant factor in contamination?
Absolutely. And but protecting the headwaters has also been a bit of a problem. Convincing people that, because they've always grazed stock, the amount of stock is increased, and so you've got the tourism, you've got the online septic systems, but you also have livestock, and that is a problem, and that's been a difficult one to address too. And the reason we chose the Sagamantha National Park is actually really, it's not silly. I went to Nepal. I went to the Sagamantha National Park with my father, who's from New Zealand. I'm in New Zealand right now, and you know, every Kiwi wants to go and follow in the footsteps of Ed Hillary. And then, so we did it, and everybody's like, "Oh, you're a geologist. You could do something about the environmental problems." And that's how I ended up. You know, people said, "Why can't you do something here?" And so I thought, well, maybe I can. And that's how we ended up working there. And then I see the next question is, how does the geology influence the water? Where the village's springs come through glacial till. So there's one village in particular that has the worst water in the region, and all of their water, their springs, are just sitting under 100 meters of glacial till, and their water quality is terrible all year round. Villages that the water's coming through rock, definitely better water quality, and some of those villages actually have, even in the monsoon season, pretty decent water, but not many of them. So the geology really has a huge influence.
Yeah. And then the next question I'm seeing for you is there seasonal variation in the data that can differentiate background levels versus tourist levels and contamination?
We haven't done a huge, we've really only sampled once in the not in the pre-monsoon dry season. We'd like, pardon me, we'd like to get some of that data, but we had a sampling trip in October, and but you run the issue, as soon as it gets cold, the bacteria mostly goes away, and so so getting the background data is pretty hard.
Yeah.
I suppose we'd like, our next goal, probably beyond this project, is to sample during the monsoon, and get, because then the bacterial content will be significantly higher.
Yeah, perfect. I see another question for Kirsten, then I see a question for both Kirsten and Gabriel. The one for Kirsten: are you planning to apply what you have learned at Sagarmatha and apply it same in other regions of Nepal?
Actually, the really horrible, not horrible, thing I'm really conflicted about is that the Sagamantha National Park is the richest part of Nepal, and it feels wrong to be doing this work in the wealthiest region of the country when you can walk a day and hit a village that has water problems and no money, no tourism, no income. And so so the short answer is yes, we would like to apply this to outside of the national park. The long answer, of course, is it boils down to funding.
Yeah, that makes sense. And then a question I see that's for both Kirsten and Gabriel. Are the respective governments in your regions involved in your projects?
I'll answer first since I'm already on. The government has to be involved. There's no getting research permits without the government, and we usually have a representative from the National Park Service with us, sometimes two, and so they're definitely involved. They're definitely interested, and they've actually, since we've been doing this work, they've really increased the money that they charge tourists. You have to pay a entry fee, and they're giving more of that money back to the communities to help address their water concerns.
Yeah. And then Gabriel, same question for you. Is the government involved in your research project?
And in our case, it's not directly. We have some partnerships with some public facilities that we gathered regional data. And as I mentioned earlier in the presentation, we have a public facility that works directly in those danger areas, which is the civil defense. So in the future, we will provide them the data and they will act directly in those areas.
Yeah, perfect. And then another question, I'm going to get to some general questions for kind of both of you, because I know, Kirsten, you kind of just mentioned funding. Like what is the outlook on like kind of the support and the funding? Like first off, like who's funding both of your projects, and what is like your outlook on, are you going to continually get funded to keep doing your research? Is your funding going to go up, down? What do you kind of see as like the outlook of the ability you're going to have to complete the research you want to do? Whoever wants to answer first about your funding.
I guess I'll go first then. So right now, Society of Exploration, SEG, is funding our research. The Geoscientists Without Borders is our primary funder right now. And in the past, we've had some small grants, university funding, and we've been absolutely shoestring budget to the point where it's amusing. And after this grant, we've been applying for National Science Foundation funding for years, and so far nothing. We're caught in between being too community, too hands-on, too human dimensions, and not enough science. And then when we do lots of science, they tell us that we haven't got enough community engagement. So we'll see. I'm not sure where our funding is going to come from.
Yeah. And then Gabriel, same question for you about your funding.
We also have the SEG funding, and in our case, we have just that. And in the end of our project, we aim to have built the entire methodology to identify those natural disasters. And the idea is that this methodology could be applied in anywhere, but we don't expect future funding to this project.
Okay, perfect, thank you. And then the next question I'm seeing in the chat is, what drove both speakers to be interested in geoscience?
So actually, before entering in the geology course, I was actually going to study chemistry, but I have the opportunity to enter in geology, and I actually was after I really started studying it that I kind of created a love for it, and especially for geophysics, using all the technology.
A similar sort of story. I started as a math physics major and got a summer job as doing geophysics, and was in the field for 4 months and loved it. And that was it. Never turned back.
Yeah. No, perfect. Thanks for sharing that. And then something I kind of want to highlight, and I brought it up before, is can you comment on like the significance and importance of communication in your work, and why your projects in particular, the community outreach, is such a crucial component?
So in our case, the the disasters affect directly people's lives. So I think we getting it's very clear to the community is a really key factor to make everybody understand the risks they are in. So because it's life threatening, so really important.
We have two observations about community engagement and outreach. And the first one is that when we first started working in the communities, people didn't ignore us, but they didn't really engage. And because they're so used to foreign researchers turning up, collecting data, leaving, and never sharing the data with the communities. And so it was probably our third year going back when people were like, oh, good to see you. What are you doing? What can we do? So there's that aspect. And, you know, communities, particularly in a big tourist area like the SMP, like Mount Everest, where scientists want to go for the novelty, those communities are used to not getting data back. Sorry. And then on the other hand, the data that we're producing, the communities really want that data. They know there's a problem with the water. They've known for a long time that there's a problem with the water, but it's really hard to fix a problem that you haven't defined. And so we've been really lucky in that we've been enough times at the community and communicate talked to enough people that they realize that we're genuine, that we're sincere, we're going to share our data. On the other hand, it's a data that they really, really want, and so we also have that community support. But that's a real issue, I think.
Yeah. No, thanks for sharing that. That makes sense. And then the next question I'm seeing in the chat, I'm assuming is directed at both of you. Is it hard to be in a field that has seen low possibilities of funding? And if so, how do you work around that, and what needs to be done in respect to any projects of such that potentially you're working on something, the funding's low? What's kind of your workaround, or how do you handle that?
For us, we have everything kind of pre-planned. We have made a plan to all of our expenses, and we try to not to diverge from that. And the founding SEG disponibilized to us, it's enough to conduct this project here in Brazil. So for this time, we're good.
Funding's a huge issue, and again, like I say, these kinds of projects fall in between that pure science and the pure, you know, humanitarian aid, and so so it's really hard to get them funded. And our workaround has always been to, if worst comes to worst, we run this as a it's not worth, it's actually fun to do. We run it as a class. And if we run it as a class, if we run the research project as a class, the equipment's already mostly in Nepal, and then, you know, students pay pretty much their living costs, their airfares and their living costs. And my colleague and I use whatever dribs and drabs of money we've got. Some years we've paid our own airfare. Some years I've used my air points to pay my airfare. You know, we can do it on a shoestring when we need to.
Yeah, no, perfect. That makes sense. And then another topic, or I guess before I get into our last couple questions here, something I want to bring up that I also had started my notes that I thought was interesting that you responded to me is the water bottles. You mentioned that like when the tourists realize that they're all buying all these water bottles because they think that's like, you know, the clean drinking source because it's in a bottle, and there's all the psychology behind that, and then there's the E. coli levels in those. Do you anticipate? I mean, it's kind of sad if it's true, because I'm assuming a lot of the locals can't afford the more expensive water bottles just with the packaging and whatnot. Do you expect the water bottles, because of the tourism, do you expect that economic aspect to drive the water bottle water quality to increase before the other water quality that the locals are using. I guess it's weird because it's like I know it's like they're coming from very similar sources, but it's like it's just who gets what water. So it's interesting to think about like where the demand will push the water quality to increase.
Absolutely. But I will say this for the Sherpa communities, they are very, I've lost the word, they are very aware of the fact that the rich lodges can afford to treat the water, and the rich tourists can afford to buy treated water, and that the poor members of the community can't. And so they've been, where they have had water projects, they're very good at distributing clean water to families that can't afford to pay for water at no cost or very, very little cost. So yes, I do think that filtered water, clean water for tourists will be, in a lot of villages, will happen first. But the Sherpa communities they're really good at making sure that it's not just the wealthy who get clean water.
Yeah, no, perfect. Thanks for that clarification. And then I'm seeing another question for you, Dr. Kirsten. Do you ever find it frustrating that funding is such an issue to such an important field? And if so, how do you push through and continue your important work and finish it?
I got really frustrated about 4 years ago, and I gave up trying to get funding for a little while. 5 years ago, I applied for everything under the sun, everything. I wrote, I don't know, 40 grant proposals pretty much 1 year, and didn't get a single one of them funded, and and got really upset, as you can imagine. So that's when I started running the project as a class for a couple of years. And then the Geoscientists Without Borders funding came through, which has been a lifesaver for the project. So yeah, it's absolutely frustrating. Like I say, we fall in between these two major funding categories of, pure science, the kind of stuff that the NSF tends to fund, and humanitarian aid. And so it is really frustrating. But it is what it is, and I can't change it.
Yeah, no, perfect. Thanks for that. That's about all we have time for today. If you have any questions that were not addressed today, you can email us at webinars@americangeosciences.org, and we'll make sure to send those questions along to the speakers. Thanks again to Geoscientists Without Borders, as well as our two speakers, Kirsten and Gabriel, for joining us today. Take care, everyone. Thank you for coming.